Hey guys, now we have another problem that involves imaginary roots. Now, as per opposed to our previous two lessons, which is the repeating and the distinct roots, imaginary roots is different from those other two. Now we have our problem, which is d4 minus 2d cubed plus 5d squared minus 8d plus 4y equals to 0. Now again, we must turn this equation into an auxiliary, so it will become m raised to 4 minus 2m cubed plus 5m squared minus 8m plus 4 equals to 0. Now we will use synthetic division to get the sum of the roots. So we're going to use 1 as our number and then input the coefficient. So 1, uh, mm, negative, negative, negative 2, negative 2 plus positive 5, negative 8, and positive 4. Now, using synthetic division, we'll just bring down 1, then 1 multiplied to 1 is equals to 1, negative 2 minus 1 is equals to negative 1, negative 1 multiplied to 1 is negative 1, now 5 minus 1 is equals to 4, 4 multiplied to 1 is equals to 4, negative 8 plus 4 is equals to negative 4, and negative 4 multiplied to 1 is equals to negative 4, so 4 minus 4 is equals to 0. Now this is a valid form of root, so our first root, which is m sub 1 is equals to 1. Now we use 1 again as our number, input the previous coefficient, so 1, negative 1, 4, negative 4, and now bring down 1 again. 1 times 1 is equals to 1, so 0. 0 multiplied to 1 is equals to 0, so 4 minus 0 is equals to 4. 4 times 1 is equals to 4. Now, negative 4 plus 4 is equals to 0 again, so this is also valid, so I forgot. Also, m sub 2 is equals to 1. Now, for the next uh, two roots, we were going to use the quadratic uh, quadratic solution in order to get them. So, m squared plus 4 equals to 0. Now, using the quadratic formula, so 0 plus positive negative square root of b squared, which is equals to 0 squared plus 4ac, which is substituted by 4 times 4. Now it will over 2 multiplied to a, which is substituted by 1. So this is the whole equation. So if you solve this, the roots will become m sub 3 equals to 2i. Oh no, m sub 4 equals to, negative 2i. As the result will be m is equals to positive negative 2i. Now we just divided it into 2 in order to input it into our y. So the answer will be y is equals to c1 e raised to x c sub 2 e xe raised to x, since it is repeating, plus c sub 3 cos 2x. Now this is because of our imaginary roots. This is the coefficient of our imaginary roots. Now plus c sub 4 sine 4x. Now we can simplify this answer into a more suitable one. So y is equals to, open parenthesis, c1 plus c2x close parenthesis multiplied to e raised to x plus the next functions as it is, so c sub 3 cos 2x plus c4 sine 4x. Now this is our final answer for our imaginary roots. So thank you for watching. See you again next time.